Okay, a quick explanation of how the system is going to work. I want you to imagine that this represents UK West, which is in Wales, in Cardiff, and this is the region which has got all the computers and servers and networks and storage and all that kind of stuff in it. And let's imagine that this is UK South, which is near Chessington, near London. Okay, so what we have over here is a VM. That VM is running off a C drive, and it has a connection to the internet, and that's called a PIP, a public IP address. It's in turn connected to another VM. That VM is a SQL server. It's got a C drive. It's got probably the D drive is reserved for the page file, so it's got an E drive, that's the next available drive, and an F drive. More than likely, this is how you'd set it up, which is operating system, data, and logs. Okay, so how does the system work? Well, what we have is, let's imagine we've got a user over here. And then what we put in the middle, just in here, in fact, I'm going to do it in blue, make it blue. That is a feature called TM, or Traffic Manager, and that's a failover solution that fails over traffic from one place to another place. So let's imagine that this user is going to make a transaction. I don't even know if you can do this, but let's imagine that they need to order some surgical equipment for one of the theatres in the hospital they work in, and they're going to use Medusa to do that, and they're going to put a transaction in. Substitute that for whatever is a valid thing to do in Medusa, but this is just to give you an idea of the sort of thing that's going to happen. So this is their transaction, this red box that I'm drawing here. And what they're going to do is they're going to say they want to go to medusa.com, which takes them to Traffic Manager, which has its own endpoint. Traffic Manager then says, well, of the two sites that I've got, this is the one that's working, and so it routes the traffic to this public IP address, which then gets routed internally into the IaaS application, which results in an update being made to the SQL server, which results in the data drive being modified. Okay, so that's one transaction. We might have other transactions going on, many things going on with many users at the same time. Now, all the time that's going on, what we're doing is we are replicating the data to some spare disks that we've got over in UK West. So we've got our C drive, we've got our E drive, and we've got our F drive. And we've also got the C drive for the web server. So let's imagine that we've done something and it's caused a change. Let's imagine we've done something that's caused a change to here, like that. Something like that as a change to the data. Then what will happen is Azure Site Recovery, which is a feature of Azure, will take that change and it will push it into the C drive in the UK South region. And then if we had another failure, let's do a circle as a failure this time. A different shape represents different data. Then we'll push this over here, and so we're constantly keeping the drives in the other region up to date. Let's do another circle over here for a change to the F drive, and then what we'll do is Azure Site Recovery will replicate this data. The replication you can configure to be I think the times are every 30 seconds, every 5 minutes, or every 15 minutes. So if you were to set it to every 15 minutes, you might lose 15 minutes worth of data because you might have got to the end of that cycle before you could restart it. But at work, at best, you could be just losing 30 seconds worth of data. Now, there's lots of other ways of solving these problems. the SQL servers that we're talking about here, the one in UK West and the one in UK South, you could be using SQL clustering, SQL always on availability groups or something like that. I'm just showing you the really simplest way to solve this problem. Okay, so let's now imagine that a failure occurs. So the failure is going to be this big cross that I'm drawing over this server here. Normally, when you send a request to a web server, you get back the page you want plus a status code. And the status code you're normally looking for is 200, which means OK. So what happens is this traffic manager is continuously sending requests into the application and asking for sometimes just nothing, just a response code, and it wants to see 200. Okay, if it sees something like 400 and something, I'm sure you're familiar with 404s, but 400 plus, not up to 500. 500 is internal server error, but anything in the 400 range, that means that something has gone wrong. And what it will then do is it will route traffic in the opposite direction. So let me give you an idea of what I mean. If this is a transaction that the user is making and things are working properly, then let me get my pointer. Then it's going to go into the traffic manager. The traffic manager is going to route it to here. It's going to come down here and it's going to live here. That works. That's working fine. But in the case of a failure, which is the failure I'm talking about is this one here, which I'm making even worse now by making the cross more angry and bad. Then what would happen would be our transaction would look like this. Let's draw the transaction out. There's another transaction. So what's going to happen now is the transaction is going to hit the traffic manager, and traffic manager is going to route it into this location. Well, we will have in the meantime detected the failure and started the boot process to boot new systems. So we've got a C drive there. You can see the C drive for the operating system, IaaS, and the Medusa application. So what we'll do is we'll create a VM on top of it, and it'll be connected to that disk. And it's going to be exactly the same as the one in the UK West. We'll do the same for the SQL server. So there's the SQL server. It boots off that drive, it gets its data from that drive, and its logs go into that drive. So that's the same as well. So this is what we're talking about. So we're talking about constantly replicating changes from one site to another site. That's UK West to UK South, from Newport in Wales to Chessington in London. In the event of a failure, then we will fire up the new side on the UK South, and we'll fix the problem in UK West, and then we'll do a failback. Okay, so what are we going to have to pay for? Well, we're going to have to pay for that virtual machine, that storage, that virtual machine, that storage, and that storage. We're going to have to pay for that virtual machine, that storage, that virtual machine, all of that storage. We'll have to pay for traffic manager. Every time we pull data out of a data center, so if we've got some data here, and we pull that out of the data center, then we have to pay for that data. It's 6.5 pence per gigabyte. So what I will do is I will give you a spreadsheet which has got the details of all the costs of all of these different things, because I could use the pricing page, but you get different pricing to what the average person and Joe Public gets. But you can see how it works, and you can see the bits of the system that you have to pay for. Oh, sorry, there's another thing I forgot that you have to also pay for, which is the thing which is in charge of doing all this replication, of getting this data, of doing this kind of thing, of getting that change just there in the data and actually replicating it across to something where there's been a failure. That is called ASR, which stands for Azure Site Recovery. And you also have to pay for that. For each VM that is protected by ASR, you have to pay for that. It's about 11 quid a month, something like that, maybe 12 or 13 quid a month. So depending on the level of protection you want, and you can have it, and it just depends on how much you're going to spend as to what you're going to get. Okay, I'll package this up as a video and I'll send a spreadsheet with the actual data in it. Hope this works for you, and talk to you later. Bye.